this lecture, we'll review one way of analyzing bivariate relationships, crosstabs, which are a way of displaying a relationship between two nominal variables. So what are crosstabs? A crosstab, which is also sometimes called a contingency table, is a table that compares two variables simultaneously. It can never compare more than two variables because simply you have only two dimensions that we're looking at. So this is often a 2x2 table, or sometimes a little bit more than that. So just going through this, the rows will be your dependent variable. The columns will be the independent variable, and then the cell will be the intersection between the row and the column. So to show what these are, I'm going to go through an example here. So let's look at the example of a study that compares gender and party ID for a data set of 68 people. Right, so you're looking to see if women are more likely to vote Democrat than men are. And so first, you determine the frequency along the first variable, gender. So how many men and women do you have? And you find that the frequency is that you have 43 women and 25 men in your data set. It's okay that they're not exactly equal, right? First is just looking to see what you have out there. And then you break out these groups, the group of women and the group of men, by a second variable. So of the 43 women, how many are Democrat? Of the 43 women, how many are Republican? And then likewise for the men, of the 25 men, how many are Democrat and how many are Republican? So we find that there's 27 Democratic women, 16 Republican women, 10 Democratic men, 15 Republican men. So the crosstab is able to take this information and display it visually in a way that is a little easier for analysis than just this list here. So here's just the original data set that we have, where you have each respondent that we've coded by one. So the first one is a Juan, and he is a male Democrat. The second one is Jenny, and she is a female Republican. Then you have Clarice, and she is a female Democrat, and so on, right? So this is just summarizing all of them up, but this is kind of a little unwieldy to look at. So we want to summarize the data a little bit better. So here we have this in the crosstab. This is the crosstab itself. So again, you have on the rows are the dependent variable, and the columns are the independent variable, right? We want to look at the effect of being a woman on which party you identify with, or effect of being a man on the party you identify with. So each box that we see here is a cell, right? And so that's the intersection. How many Democratic men do you have? How many Democratic women do you have? This part here is the row, and this is the column, okay? So sometimes you also preferably have additional information, which is that you have the totals, also known as the marginals, right? So you want to add up how many Democrats total that you have. You had 37 Democrats, of which 27 are women, 10 are men, right? So you add up here this cell plus this cell is that, right? And then likewise, 27 Democratic women, 16 Republican women, 43 total women. So this is the total number of Democrats, total number of Republicans, total number of women, total number of men. And then here, they'll add up both exactly the same, which is the total sample size that you have, which is 68. Okay. So here's just adding them up, the total n. So it's easier to interpret this with column percentages than just those raw numbers. So here we have taken this and divided it by the total number, right? And so we see that of the women, 62.8% are Democrat, 37.2% are Republican, totaling up 43 women. So it should add up to 100% going down the column. And that's because women are the independent variable, right? And so you want to look at the effect of being women. So among women, how many are Democrats, how many are Republicans? Likewise, among men, how many Democrats and how many are Republicans? You're not as interested in among Democrats, what's the percentage of women and men. You're more interested in seeing among women, how are they broken up, right? So here are the original raw numbers that you divided. 27 by 37 gets you 62.8. 10 by 30, or sorry, 27 by 43 gets you 62.8. 16 divided by 43 gets you 37, right? Likewise, 10 divided by 25 gets you 40. 15 divided by 25 gets you 60%. So again, you're always dividing by what's here at the bottom, right, instead of what's over here. And so just thinking through this a little bit more intuitively, if you want to think about using the crosstab as a visualization of your data, it works best when you have nominal or less ideally ordinal data. If you moved into something that's like ratio data, such as years of education, so you want to look at the effect of having education on your party ID, it gets really unwieldy really quickly. So you have all of these data points here, all these cells, and then trying to make real meaningful comparisons between people who have 9 years of education with people who have 11 years of education, it just becomes too much to handle. So it no longer helps you visualize the data. Even more so if you had, say, feeling thermometer for Obama, which is an interval variable, with years of education, which is a ratio measure. If you were trying to fill in all of these cells, it's just completely unwieldy. And so this is not the best kind of test to use when you have interval or ratio data. There'll be other tests that we can use that'll be more useful in that. So finally, I just want to end a discussion of what we do with crosstabs. We're not going to do this in this course simply for simplicity's sake, but the test that you use to actually see if there's a statistically significant result is called a chi-squared test. And so this is the test to see if, the difference between having 60% and 40% in two cells, if that's really a meaningful difference, or if that's simply something that we might observe due to chance. So we're not going to go through this, but this is just something, for you to know about why we would be talking about this. For now, we're simply going to be using crosstabs as a way of visualizing data and looking into patterns that we see in the data, more for just observing correlations than for testing statistical significance.